Picture the classic desert. Blazing sunlight, wind-carved dunes, and a horizon that seems to have forgotten what a cloud looks like. If you enjoy surprising facts explained clearly, subscribe to Dr. No for a new discovery every day. It feels natural to assume that deserts exist because they are hot, but that explanation gets the story backward. A desert is defined mainly by dryness, not temperature or sand. Regions commonly classified as deserts receive very little precipitation, often less than about 250 millimeters or 10 inches in a year. That means a desert can be scorching, freezing, rocky, foggy, high in the mountains or close to the sea. The real mystery is not why deserts are hot. It is why so many places repeatedly miss out on rain. The answer begins high above the ground, inside a planet-wide circulation system powered by uneven heating from the sun. Near the equator, sunlight arrives more directly than it does at higher latitudes. Warm, humid air rises there. As it rises, the air expands and cools. Cooling causes water vapor to condense into clouds, and that is one reason equatorial regions often receive abundant rain. But air that has risen cannot keep climbing forever. High in the atmosphere, it spreads toward the north and south. Eventually, much of that air descends again, commonly around 30 degrees north and south of the equator. This descending branch is one of the largest desert-making machines on Earth. As air sinks, increasing pressure compresses it and warms it. Warmer air can hold more water vapor before it condenses, so clouds struggle to develop. The sinking air also discourages the upward motion that storms need. That is why many of the world's great hot deserts cluster in the subtropics. The Sahara lies near this broad belt of descending air. So do major dry regions of the Arabian Peninsula, southern Africa, Australia, and parts of the Americas. Their clear skies and powerful sunshine are not the original cause of the dryness. They are, in part, the visible result of an atmosphere that repeatedly suppresses clouds and rain. This circulation explains a pattern, but it does not explain every desert. Earth has several ways to keep moisture away from land. Mountains provide one of the most dramatic. Imagine moist air blowing toward a high mountain range. Cannot pass through the mountains, so it is forced upward. Rising air cools, and cooler air cannot hold as much water vapor. Clouds form. Rain or snow falls on the windward side, the side facing the incoming wind. By the time the air reaches the crest, much of its moisture has already fallen out. Then the air descends the far side. As it sinks, it warms. Clouds evaporate or fail to form, and the landscape on the leeward side receives far less precipitation. This dry zone is called a rain shadow. In the western United States, Death Valley is part of a landscape shaped by rain shadow effects associated with mountain ranges including the Sierra Nevada. The effect can be startling. One side of a mountain system can support forests and snowfields, while land beyond it becomes dry basin, scrubland, or desert. Mountains do not create dryness from nothing. They intercept moisture that might otherwise travel farther inland. Then there are deserts that seem to contradict everything people expect. Along some west-facing coasts, cold ocean currents help produce dry land beside the sea. Normally, the ocean is a great supplier of atmospheric moisture. Water evaporates, humid air rises, clouds build, and rain can follow. But where cold currents cool the ocean surface, the air immediately above it may become cool and stable. A stable layer of air resists rising. Without vigorous upward motion, it is difficult for rain-producing clouds to grow. This can create a strange coastal world. Fog drifting in from the sea, high humidity near the ground, and yet very little rainfall. The Atacama region along the Pacific coast of South America is a famous example of a coastal desert influenced by cold ocean water, atmospheric stability, and the barrier of the Andes. Fog can be present even when rain is rare. Moisture is nearby, but the atmosphere is not arranged to turn that moisture into showers. This is an important distinction. Humidity does not automatically mean rain. Rain needs a chain of events: moist air, cooling, condensation, cloud growth, and often enough uplift for droplets or ice crystals to become heavy enough to fall. Break that chain, and a place can remain dry even beside an ocean. Distance from moisture sources can also matter. Deep inside a continent, air masses may travel vast distances before reaching a region. Along the way, they can lose moisture through rainfall elsewhere. If mountains block the remaining supply, or if prevailing winds do not carry moist air in regularly, the interior can become arid. The Gobi Desert of East and Central Asia shows how several influences can overlap. Its inland position limits easy access to ocean moisture, while surrounding mountain systems help shape where precipitation falls. It is also a reminder that desert does not mean tropical heat. Winter there can be bitterly cold. In fact, the coldest deserts reveal the simplest rule of all. Deserts are dry because little water falls from the sky, not because temperatures are high. Polar regions receive so little precipitation that Antarctica is classed as a desert. Much of its precipitation falls as snow, but the annual total is extremely low, especially far from the coast. It is an icy desert, not a sandy one. Why does cold air make polar areas so dry? Cold air holds far less water vapor than warm air. With little water vapor available, there is little precipitation to deliver. Antarctica also has powerful winds, high interior elevation, and a climate system that keeps its center exceptionally cold and dry. It looks nothing like the Sahara, yet both landscapes share the defining condition of desert: a long-term shortage of precipitation. Once dryness takes hold, it changes the landscape in ways that make deserts visually unforgettable. Sparse vegetation leaves soil and rock exposed. Wind can lift and transport loose grains. Sudden storms, although infrequent, can cause flash floods because dry ground may absorb water slowly and runoff can rush through channels. Temperature swings can fracture rock over time. Dunes, gravel plains, salt flats, canyons, and bare mountains emerge from the combined work of wind, water, and long periods with little plant cover. But deserts are not empty spaces waiting to be filled. They are living systems shaped by water scarcity. Plants may store water, reduce leaf area, grow deep roots, or remain dormant until rain arrives. Animals may shelter underground, become active at cooler hours, or obtain much of their water from food. In the American Southwest, the timing of rainfall even separates desert types. The Mojave, Sonoran, and Chihuahuan deserts receive important summer precipitation, while the Great Basin receives much of its precipitation in winter. That timing matters because a desert is not merely an annual rainfall total. It is also a rhythm. A brief summer storm season, a winter snowfall pattern, a rare coastal mist, or years between major rains can decide which plants survive and which animals can live there. There is one final twist. Deserts can change. Over thousands of years, shifts in Earth's orbit, ocean conditions, ice sheets, vegetation, and atmospheric circulation have altered where rains fall. Even landscapes that seem permanent have wetter and drier chapters in their history. Human-driven climate change is also affecting rainfall patterns and drought risks in many regions, although it does not turn every dry spell into desertification. A desert is a climate pattern measured over long periods, while drought is a temporary shortage of water relative to normal conditions. So the next time you see a dune sea or a barren valley, do not see it as a place where rain simply forgot to arrive. See the invisible forces behind it. Air sinking from the upper atmosphere, mountains wringing moisture from passing winds, cold currents stabilizing coastal air, enormous distances from oceans, or polar cold limiting water vapor from the start. The desert is not created by emptiness. It is created by a remarkably organized absence, the absence of regular precipitation. And once you know where the missing rain went, the world's driest landscapes become a map of Earth's moving air, rising mountains, and restless oceans.